I do want to start the stream. Hello! Am I streaming? I am. Good. Awesome. Alright, welcome back to Coding Meta. I'm Court Campbell. And I'm going to take those headphones off. I should sound a little bit better today. Previous videos, not so great, but doing it a little bit at a time, making it a little bit better every time I do it. So, got a little bit of Moby playing, hopefully not too loud so as to get busted. Alright, so today we're going to cover deploying Grub in a GCP managed instance group. So let me talk a little bit about the doing that, actually setting that up and creating it. First, if you're not familiar with the series, I guess I should always do a little intro because these are usually about 2 hours. I try to keep them to 2 hours. I probably will do 2 of these today because I have a lot to do. And I call them days, but I mean, it's 2 hours, so there's no way that you should watch me more than 2 hours a day. So it's another day, another episode for each episode. You just treat it as a day. I saw this thing the other day on Hacker News, and they were talking about, I'd go pull it up, but it'd just be a waste of time. You can go look on Hacker News if you want to for it. I was talking about the amount of time that people actually spend coding a day is like, I think 7% of their time is spent coding while they're working, if you're a programmer. And then the rest of the time is all this other busy work. And that is true, but when you're first starting out, you can get into the flow. If you can get into the flow in a day and you can get into the flow, you will crank out quite a bit of code if it's in the early days. So if you have a lot to do, a lot of things on your list, if you're using a ticket system like I do on GitHub, you can create more tickets for yourself than you can write code for sure in a day. But there is a lot of overhead in managing code, and as it's created and then later on managing it, it can become more time consuming to manage the code than actually writing new code. So with that said, I have a lot to do here. I have, just like a lot of other people when they're creating something or creating a service or a company, you frequently, I'm sure there are some people who can estimate it and get it pretty close to how long it's going to take, especially if you've done enough of these. But I always underestimate it, and I always usually say if I take the guess, it's usually twice as long. So I thought I could get this done before the end of the year, and kind of made it work, but it was so brittle and really didn't work very well. And one of the things that I needed to do was what we're going to cover today, which is setting up an instance group on Google Cloud for the crawler, the thing that images. So if you're new to the channel or whatever, everybody's new to it, I guess, so I'll just explain it instead of saying that, is that I'm creating this site called meta.us. So meta is short for measure in Old English or friend in Pali. So I like to think of it as your measured friend. And in this case, I call them sidekicks, and that's just a search index. So sidekick is a search index. So I'm selling search indexes, which are being run on Solr. And that's not an uncommon thing. There are other services out there that sell search. And I've sold search before, and so I'm going back to selling search again. But I'm adding what I created before I went into search, which was a web crawler. And this is a new type of crawler, and we're actually going to be talking about this today, as promised in previous episodes. And so I guess this is the announcement for the new version of Grub. Grub was a web crawler that I and a few other people created back in the early 2000s, and we sold it to a company called LookSmart. LookSmart later sold it to Wikimedia. Actually, Jimmy Wales wanted it. Jimmy Wales is the guy behind Wikipedia. If you Google all that, you can kind of discover a little bit about it. And he bought Grub because he wanted to build a new search engine. And I don't think they ever did that. So here we are. I'm taking Grub, the name Grub, back, and this time we're going to keep it open source. LookSmart bought it, and one of the first things that they did after they bought it and hired our team and brought us out to San Francisco, actually this is what originally brought me out here to begin with from Oklahoma, is they wanted to close source it. And I wasn't particularly excited about that, but because they had paid me a lot of money and there wasn't really anybody contributing code other than us. If I recall correctly, we had our code on Google Code, which was an open source, it was kind of like GitHub. You could put your code on there. I think it was CVS was the repository type that was being used for Grub. And I remember whoever was, I have to think back about what his name is, but one of the guys that was running the Google Code site, well, they got mad that we closed sourced the code. And I can get that, but fortunately for us, there was no one else that had contributed to code, and everybody that wrote the code got paid for being bought. And we thought that LookSmart was going to take it and do something interesting with it, and they never did, and ended up selling it, I think, for $50,000. So we really got the good end of the deal, especially me. And well, yeah, I mean, it never went anywhere. And at one point in time, we had a lot of people crawling for Grub. Grub was an open source distributed web crawler. We had a bunch of URLs that we would do discovery for, both through our own crawling efforts and as well as other people crawling. And we would extract those URLs with the software. It ran on your computer. I say your computer, it ran on other people's computers that wanted to contribute to it. To the project, and then we ran a server that would dish out URLs for people to crawl. And it was interesting, but it didn't really do anything with search. And we had people asking us for the ability to, add their own curated content. They wanted to submit their own web pages and then be able to search those. And while the use cases, honestly, I just have to think about what was emailed to me and the contacts that I had at the time were asking for. But it was essentially the ability to create your own search engine, which is somewhat of what I'm doing with Meta, albeit in a very narrow definition, which is you can go to a site, you can give us a URL, we'll snapshot it or take a picture of it, and then, like Pinterest does, but then we pass it to machine learning libraries for content analysis and extraction of interesting things that are on the page, like snowflakes or whatever. So that's sort of maybe a half-assed summary of what Grub was, but my original intent for Grub was to distribute the job to people, to be able to give it to people to say to us, hey, what's interesting? If you look at the way Google works, is Google tries to look at as many web pages on the internet as possible with their crawlers that they run. And then the results are pulled back, and then they do extraction of the URLs that are in the pages. PageRank is one way that Google does ranking of pages for search result return. So when you do a search and they rank a page up at the top of the page when they give it back to you, one of the ways that they rank it or they sort those for you is by looking at how many links link to that page. And in the early days of the internet, that was actually a pretty good way to do it. But in modern times, it's still probably still somewhat useful, but there's an awful lot of web pages out there, and a lot of them are created intentionally to increase page rank. So you might find a page on the internet that just has a bunch of links to a bunch of sites that person that created the page is being paid to link to. And so that's not particularly useful to individuals looking for interesting content or wanting to remember interesting content. It's absolutely not useful at all. And so Meta tries to address that by just letting you tell us what to crawl. And then we show it to you, but then we're using machine learning to decide whether or not that content should be ranked high or not. And we haven't really gotten into how we're going to do that yet, because I haven't written that code yet, but I know it's all up here. And we have Solr to do that for us as well, which makes it really easy. So when we get to it, it won't be that complicated. It'll be pretty straightforward to do that for the system. But in order to do that, we have to get the data first, and that's where Grub comes in. Grub is the crawler. That's the crawling portion of it, and it is open source, so if you're interested in checking it out, it's under my repo cordless/grub-2.0. And I will say that I'm not going to go through all of this, but if you want to understand more about it, you can read all of this stuff that I've written, but the most important part is the install if you want to get it going. And if you want to start either a Grub server on GCP or a Solr server, you can use this repo to do that today. But it doesn't have the code yet for tying all the pieces together, which will include Tensorflow for analysis of the content that's being pulled back, as well as a system for storing the images that are coming back from imaging the sites. So with all that said, I'm going to jump in now into talking about how you can take Grub and deploy it as a managed service on Google. And so I'm going to show you what that looks like now. So if you go into I have all these pinned, so these are the most important parts to me. So I am not yet running any containerized services. Eventually, so the Solr scripts will be containerized and run inside of Kubernetes. I just don't want to pay for a Kubernetes cluster right now. I'm not ready to launch, and it's just easier for me to run Solr on its own instance, on a preemptible instance, which runs for 24 hours. So if you go into Meta and you try to use it and it's not working, let me go ahead and log in here and kind of show you what I'm talking about here. It's broken a lot. And when I say a lot, it's going to be broken more frequently than it is working. But over time, that will change. All right, so I got a code here, 192.605. This is Meta's passwordless authentication. All right, so what we're going to do is we're actually going to tell it, it's probably not going to work, but we're going to tell it to index news.google.com. We're going to try to get this working again today, but I don't think this is probably working. And the reason why is because, so the index is down, so let's go check the instances. I don't know if the index is down or if the Grub server, I think the Grub server is down. No, the index is down. So this is what I was talking about. This instance is preemptible. So I think this is running on a, let's see, how big a box is this? It's a 10 gigabyte disk image. I'm just making it 10 gig because right now there's no reason to make it bigger. It's a N1 standard 4 with 15 gigabytes of memory. So I think this is about $30 a month. If it's running all the time, it's about $30 a month. It usually is about $20 a month or something like that. That's been my experience. I work on it pretty much every day. So every day I'll jump in and start it. Most days I'll start it. I was gone for a couple of days this week, up running around in the Sierras, and I didn't start it then, so it would be down. But as long as this Solr instance is running, you should be able to use Meta. So the whole idea being that Meta allows you to give the site a URL, and then I'll image it. So I take a picture of it, and I take a picture of it with Grub. This is the code over here, this is the Grub code. And so I have a Grub server running. And here's how I do that, is I can run this script, deploy Grub. If you have all of this stuff installed locally, I say stuff, the Google Cloud SDK installed locally on either Windows or on the Mac, or here where I'm on Windows, but I also have it installed on my Mac laptop. You just do a /deploy grub and run it, and it will actually tell Google Cloud to start up a Grub instance and run it. Now, one problem that is sort of an issue right now with the script is that the address, I have an IP address in here hard coded. If you wanted to run this, in fact, I'm just going to comment this out. And just so that if you do want to run it, you can start it and it won't matter. So I'm gonna, I think I can comment this out here. I think that'll work. So that way I don't have it dedicated using a dedicated IP address. Let me go ahead and just start one and I'll show you exactly what it does. So we're gonna go back. Well, that Solr instance, the Solr instance is designed to restart itself, and when it's shut down by Google, it actually shuts down Solr automatically so that Solr is cleaned up after itself when it's shut down. So so let's start that into the Google Cloud Shell. So what I need to do first is look and see here. So I'm going to remove the static IP address and then I'm going to push that. And then I'll do a git pull. This repository has moved. It says it says that it's I guess that's just a warning that it's moved. I don't know, whatever. And so I guess I changed the type of box. I'm illustrating it in the Google Shell. You could run this local. I could totally run this locally and it'll start it. I'm just doing it in here because it's a little bit easier. You don't have to have the stuff installed locally to run it. So I can just illustrate it here a little bit easier, I think. Assuming that I do have the secrets file there. Okay, so git pull. Yep. And then deploy grub. And then this should start a Grub instance. This is a standalone instance that'll start it as a preemptible instance. And this is how I was running it before. Saying metadata not found. Well, it doesn't like this. I'm just going to take it out. I mean, another thing that I could do is make it look like this. Because if I put that default in there, I don't know, maybe that'll work. Let's see if this works. I'm going to change this to where it does not contain this line. Alright, I'm going to commit that again. Push it. You can see my token now, so that one's spoiled. I'll have to change it. So the token is stored now that I've blown my cover. I forgot it printed it out. I'll just cat it, but this is the way it works, is that you take the secrets file. This is very simple. It's secured with Nginx. So the system, what it does is it'll launch once we get it working, it'll launch a instance, and then it assigns a token to the box, and I'll show you that here. And so I'm actually kind of glad it blew my cover. I need to change the password, that token anyway. That was just kind of a hacky token anyway. All right, let's try this again. Whoops. All right, good. So in this particular case, because I took out that IP address statement in there, it won't assign it a static IP address. If you put that -- address in there and you have a static IP that you've assigned through your static IP addresses, which are external IP addresses, if you have a static IP address in here and you've given it a name, and you have the static IP address, you can just put it right here with -- address, and then it will start that instance with that external IP address. It's a reserved address. So I had a couple of them in there that I had created, and it likes to give me this one all the time, so it's kind of interesting that it assigned it to it. But so now you can see it's running. I think I actually have 2 of them running now. So 2 grub boxes, 2 more new grub boxes. And you can see that when the script runs, I name it, I give it a little hash at the end of this. I kind of, I guess I picked that up from, I just picked up that idea from somewhere, but it's interesting that they do that with these managed instances as well. They put these little hashes on there. I kind of got the idea from Docker. When Docker starts up a Docker instance, you'll get a Docker container, you'll get these little hashes on the end of here. But so now, if I were to talk to one of these boxes, and I'll do that now, I'll just copy this. I hope this works. Let's actually secure shell into this guy and make sure. I don't want to flounder around here. I've been watching my videos, which is somewhat useful to me to watch how I work. And how I work when I'm streaming is different than how I work when I'm just working, because I'm not talking when I'm just working. But when I'm streaming, I sort of feel the need to talk, and so it is what it is. Okay, so is it running? It doesn't look like it's running. And the whole thing is here that I should see, Nginx running. So I'm going to go in here and look. Yeah, I don't see anything in there starting. I don't know what's going on with that guy. Why is it not working? Let's go look at the other one. This one. I'm just looking at the logs. So this one is working. So maybe the other one didn't work because it had an error or something? I don't know. So is this one right here? I'm just going to delete it. So this one should be working. So I'm going to copy this, and then I'm going to go to curl it. And it is not secured, so that's just the way it is. Let's see if I can remember the paste command for this. Nope. I don't want to I want to curl. And then 89, 83, and then the health check. Okay, so this is working. Okay, so here's how it works. If we go back to the Grub page, we go down here and we say something like this right here. So we're going to tell it by making a call to the API that's running on the Grub box. We're going to call it and we're going to tell it to, well, wait a minute, let me think about this. That's the wrong IP address. And we want this part right here. Okay, so that's shift insert. Yes. Okay, and then we've got, it's 34.83.107.152, and it's running on port 8983 slash G, which is for Grub. And that's telling it to post that. Okay, so that's telling it to post news.ycombinator.com/news. And then it's going to give it the username is Grub, and then I need the password, which we've now been outed with, which is this token. And this is passed to the Nginx server. Port number ending with F. I need an @ sign here. Not found. Exit. What did I say here? Can't even remember what I said. Well, it says G. What's wrong with that? HTTP. So I'm doing a post. -D. So that's my, oh. I think that's supposed to be URL equals. Yeah. Well, that's a typo. URL equals. Okay, now it's working. Keep in mind we started this instance, so this is the one I'm calling. And it says that there was a success, and then this is the file name. So that's what it does right now, is it returns this file name. That's part of what we're going to be hopefully changing today, is how this thing responds. That's why we're working on it. Okay, so I'm going to copy that file name, and then what am I going to do? I need to copy this. Yep. All of that right there. So I'm going to copy that. And I'm going to go back here. I'm going to start a new tab. And then I'm going to paste this in. And then I'm going to say, let's see, what did I say here? And then it says images and then the file name. Close that tab. Okay, good. I thought I wasn't streaming for some reason because it didn't look like I was streaming. All right, so this is images, and then I'm going to go back and I'm going to grab this image name, and I'm going to copy that. Control insert to copy. That's kind of weird. Why can't they just make it Control V? Okay, so that looks pretty good, and there it is. So what happened was Grub was, what we did is we posted from this computer, we posted a curl post statement to the API, which is handled by this route right here. And it loaded the URL. We need to go in and change the docs to say URL equals, and then what it does is it extracts the URL from the post. You can see here it receives a post. This is Flask. I use Flask exclusively in Python. And then if there's no URL, it says go away, 404 not found. And then it says it says I'm going to assign a file name, and it runs this thing called check output, which is this sub-process thing. And sub-process is like a way to remotely execute, or is like a way to shell out from the Python into the shell and run a command. And what we're doing is actually running Python from the shell. Now you're like, why are you doing that? Because you could just call it from Python. And the answer is because this is like browser session. That's all the code is in there, so if you want to go look at it, knock yourself out. It's all in this directory called Aperture. So I'm like calling the system that's imaging this stuff Aperture, but it's really just WebDriver. I had a friend named Joe who wrote or provided the information for how to do this and wrote some of this code, the browser session stuff. And what I found was that whenever I ran it in context of the Flask application, that it would bomb. It's basically not made to be continuously running. So it would say, oh, well, I already have a session established. So it would work the first time, and then the second time it wouldn't. And I started to dig into it, and I have all this other code to write, and I just realized that if I just ran it like this, it would actually restart the process every single time somebody posted something to it. So in my mind, because of that, and because you can run, it's essentially a web browser running inside of the browser session stuff, runs a web browser like Selenium does. It's for testing UI stuff, but in this case, I'm just using it to image the page. And like I was thinking about, well, if you start it and then you've got this browser running, then somebody could submit something again and there might be a hole there. And so if by running it with subprocess, I get away from all of that. This will fire it up and then it'll tear it down. So basically it fires up Firefox and then tears it all down again. And that does increase the amount of time that it takes to do that. But because it was going to take me time to figure it out, which, you know, if I figure it out, then I figured it out and then it works. But I just didn't want to do it. And so this is how you code. Sometimes you just go, I don't want to do that. I want to worry about something else. And so in this case, that's what I did. But I did it under the guise of, well, probably increases security too, because I don't know a lot about how that code works. And there's still some questions that I have about how it works, but I got it working. And so there's no need to get super complicated about it, because I can go back and fix it later, or I can hire somebody to go back and fix it later if this turns into something that ends up making money, which it might not, because it's a startup. I mean, 9 out of 10 startups fail, so why take the extra effort to do it, or even bother explaining it on live stream? So after I get the file name back, then I return a result, and I include the file name in there, which you see here. There it is. This is where that result comes from, right here. And that's it. There's not really a lot more to it. This is the entirety of the Grub server as you're looking at it. And so it's super simple, but a little bit complicated behind the scenes, because it does generate what looks like a web page for you. And that's what we want, is we want this image coming back. Now, there is probably a lot of opinions about how to crawl the internet, but in the case of Meta and Grub here, I'm changing the idea of how this works a little bit in crawling a web page. When a human crawls a web page, if I go to news.ycombinator.com and I look at it, this is what it looks like to me. But obviously, if you're in the know and you go to view page source, you know that this is actually what the web page looks like to the machine. And the problem is that, as you can see here, let's see if we can find something that says description. You see there's nothing that says description in here, but if you have a meta name description in your web page, it's possible to go in there with code and extract the description. But in the case of Hacker News, they just don't care. In fact, this code is really old, that it was written to run Hacker News. And they just don't care. They don't care if you index them. They just don't care. They just do it. They do what they do, and they do it on their own, in their own way. And that's fine, because it's their web page. But if I'm crawling them, I want a consistent way to look at all web pages. If I'm looking at CNN or Hacker News or whatever it is, I want to be able to give the system that I'm using a way to consistently look at them and look at the pages, some way that's consistent across all websites. And that way to do that is by taking a picture of it. Now, I'm not logged in here, and I can't select things, so if I had, you know, like mousing over this, I can't select any of this. It's all been turned into an image. But that's actually okay, and I'm going to show you exactly why. So I'm going to save this image, and I'll save it on, let's see here, the desktop. And then I'm going to go to, let's see, I always forget. It's Google Vision Try It. This is always how I find the page. This is how we search for things, isn't it? Like remember or bookmark things. We remember what they, right? And so let's see, what is that file name? It's, I don't know what I did with it. Let's see here, date modified on the desktop. Yeah, that's it right there. And I'm not a robot. So this is, Google Vision is their AI. And so that ran pretty fast, and it said that it's a screenshot, which it is. It's, I don't know what all these things are, rectangle, paper, people, product, document. That's what it thinks the labels are that it's assigned to this. It's like saying, I think this is what I'm looking at. Most of these are useless when you're looking at just text. But the great part is all of the text has been extracted. So if you go down here and look, you have all of the text available to you. It's all right here. Every single bit of it. Now that's because Google has an AI or a machine learning library that extracts text. So why look at the source and then try to figure out where that text is when you can just run an AI on it and get that text back? You can see here what I'd have to do is I'd have to pull out the text entity or the text object from the HTML. And yes, well, I would have the links, but in the case of Meta, I don't want the links. The only links I take are from the users. The users are the crawler now, in my opinion. That was always what Grub was about, was making the user the crawler. If I wanted these links, I could just simply tell it that I want to look at the source. So I could pass Grub a command that says give me the source back, and I could get it back, and I could even image it if I wanted to. So I could image that, and then I could pass that to Google, and then it would pass me back all the text, which includes these links. I don't have to look for href tag or anything like that. I could just look for links in the text that Google returns me using regex or something. So I'm sort of throwing the idea of looking into HTML completely out the window, and the reason why is because there's no standard about how it's done. There are some standards about obviously how a link is made, and I could iterate through with Beautiful Soup, and I could look for all the ahref tags, and I could extract all of those. But the problem is that people just spam the crap out of tags, or I'm sorry, links. URLs or URIs in their documents. There's just no standardized way to do it. You can see here, even on Hacker News, you've got this ahref, and it's not even a complete URL. It's like a stub. So I have to know the page I'm looking at, and then I have to take the stub and add it to the end of the URL. Well, I mean, that's a lot of work to do that with code. In the case of just imaging the page, it makes it super easy. I don't need to know what this link is. I need to know what the text is on this page because somebody told me to bookmark it. And if they want to bookmark this page, well, then they can click on the link themselves on that page, and then they can go and tell me to bookmark that page. All right, so I've talked enough about that. Let's go and do one that is not Hacker News. Let's do this one. And let's see if it works. So this is Arvix. I always call it Arvix, but it's actually not Arvix. It's RXIV. I don't know how you say this, but it's a place where you go look at PDFs of things, of papers. And so what we're going to do here is we're going to do the same thing, and we're going to go over here and we're going to paste in this other URL instead. So it's shift insert. Yep. All right, enter. You can see this takes a little time, so it's already been 10 seconds. There we go. It runs faster on a faster instance, but I don't care. It's going to do it. Person's going to paste it in. It's going to go. We're going to talk about this in a little bit. Where it's going to go and actually use Beautiful Soup to try to get the title of the page and the description if it exists. It will try to pull that out of the HTML, but that's the only thing that I'm doing with the system. We're going to talk about that here in a minute when I get back to it. Now let's see if this worked. So we have this one, so let's just paste in this other thing. And there it is. So now I have, it's the exact same thing, it's just another page. Now, there are probably a lot of different ways you can do this. I think that I used to have a plugin here in the browser which you could click on and it'll image the page as well. So there's a bunch of different ways you can take the images of pages, but in the case of Grub 2.0, this is the way you do it. You start a Grub server and then you just post the URL to it and it gives you back the image. All right, so we're done talking about that and a little bit about how Grub is going to use machine learning to be able to extract that stuff. So I'm going to turn this instance off because I'm done with it. And then what I'm going to do is I'm going to take this, let's see here, this IP address. I'm going to skip ahead here for just a second. I'm going to take this IP address right here, and I'm going to copy that, and I'm going to put that in my minute configuration. And I'm on the fence. Let's see, if I do that, you're going to see other tokens. I'm trying to figure out if I'm going to show you the config stuff, I'm going to have to change all of these things. I'm just going to do it, I don't care. Well, I probably shouldn't because it was my Twilio account stuff, but whatever. It's already out now, so I'm fucked. So I'm just gonna have to change all of them. That's fine. I'll do it after the stream. I think it's good to show this once. So this is the one time that I'm going to show you this stuff, and I'll be right back. Hello? Alan? Yes, that'd be good. What do you want to go? No, I'll be done probably in about an hour. You want to do that? 2 minutes. Okay, let me get done with this screen and I'll head over and we'll go. Okay. Okay, sounds good. I'll call you about an hour. Love you. Bye. So I'm going to go through this configuration file really quick with you. So I have a SendGrid key here, so that'll need to be redone. I have a Twilio account ID that's in here with Twilio number. I'll reset that. And then I have a Flask key, which is not really that big of a deal, and a jobs token, and a Flickr key. I don't know why that's in there. I'm just going to delete that. I don't even think that's even used for anything. I don't know why I have that Flickr key in there. I think I was testing something. And then the password that we were talking about earlier, and that's used for the Solr box. So I'll just change these. So the big one that I need to change here is the Twilio key and the SendGrid key, and that's really easy. I'll just log in and change both of those. And this secret key, I'll update it as well. Just because, I mean, like, yeah, I could leave it in there and it probably wouldn't be a big deal for a while, but eventually somebody will watch the stream. And it's weird with streaming, we're broadcasting. I talked about this a little bit the other day. You're broadcasting your screen. I mean, like, it's like, oh my gosh, well, did I look at something that might be offensive or something? You just have to not care. I just really don't care. You want these keys, go knock yourself out. You're not going to do enough damage. I need to know, and you need to know, if you expose your data visually to people, you need to know that they can extract it from an image. I mean, that's what we're talking about today, is extracting data from images after all. So good security requires that you be aware of these things. It's not whether or not you do it or not. I mean, it's kind of okay to do it as long as you go and take care of it. So after this, I'm going to take care of the secret keys, the Twilio account keys, and the SendGrid keys. Those are the important ones, right? So in this configuration file, we've got this. This config file is for Meta, which runs on AppEngine. If you've been following along, watch the other videos. You'll kind of get a little bit better idea what's going on. This particular IP address for right now is actually the address that the system uses when it needs to go have something crawled and imaged. So in this case, what happens is the AppEngine code that's running on Google, when you go to Meta and you tell it to image or to crawl a site, it says, okay, I'm going to go call a box. And that box is running Grub, as I've illustrated here earlier. It's running Grub, and then it uses Selenium WebDriver to go and image the page. And then it returns where that is, and then it uses it to download it and put it on in Google Cloud Storage. That's what Meta does on the back end of behind the scenes. When you're typing in, say, hey, save this page, that's what it does. Is it goes off, pings a box, the box crawls a website, the box images the website, it saves the image, and then the AppEngine app then downloads the image and saves it into Google Cloud Storage. That's how it works right now. So the problem with that previously was that I did not have a way to talk to multiple boxes. So what we're going to cover right now, I'm just going to check my time. It's 47 minutes, perfect. So what we're going to cover right now is how to make that scalable. And I needed to do that, and so I went and did it. And the reason why is because I use preemptible instances, and that's fine because they're cheap. But if they go down, if Google takes them down, you need to restart them. So there's a way to do that with Google automatically, and that's by creating an instance group. In order to create an instance group, though, you need an instance template. The group is the thing that is managed, so it needs an instance template. In this case, I've created a group called Grub Group, and it uses a template called Grub Template. And the template is based on, in this case, the template is based on the template or the script that I created for starting a Grub instance. So what we're going to do is we're going to go look at the deploy grub script again, and here we have that script right here. So what we're going to do is I'm going to walk you through creating another. I have this running right now, but I'm going to walk you through how I did that. You can see it's $24.86 a month estimate to run the instance. So I'm going to call this I don't know, stream template. Grub stream template. And what I did is I selected a compute optimized instance. Did I? No, I did not. I actually ended up using a general purpose one because it was cheaper. I did the 8 gigabyte memory. If you do a compute optimized one at 16 gigabytes, it takes that imaging time down to about 4 seconds. So once I go into production, I'll change this machine type to a faster instance because in the interest of expenses, keeping expenses low, there's no sense in spending $100 a month if I'm just doing development. So I want to keep those costs low, so I make them preemptible instances. So in this case, I'll just leave it as this. And then what I did is I went in and I clicked on the management section, and I went into the startup script and I pasted this script. So I'm just going to copy this verbatim into this area. So now I have the startup script in here. Again, the startup script is on GitHub, so if you want to take a look at it. please do. And then I'm going to go into networking, and I'm going to go into the network tags, and I'm going to type in grub and comma, and then I'm going to type in token and dash, and then I'm going to go back to my secrets. In this case, I'm just going to use this one, just because I'm doing an example. It doesn't matter. Well, all right, token. I can't select it again and type again, I guess. And I'm going to hit enter, and that is how the box learns its own token. So when you use this type of methodology, which is you have boxes talking to each other, you can essentially, inside of Google, I mean, nobody inside of Google is going to get, I mean, probably no one inside of Google is going to look at your tokens. This is not the most secure way to do this, but in the interest of developing something without going completely nuts with security, it keeps things pretty secure. So this box will be able to know about its token, and I say this box, any instance created with this instance template will be able to learn what its token is for talking to things. So there's a system token that's passed around, which we saw again was inside of the configuration file, which I'm not going to show again. So in the case of the external IP address for these instances that are started, they're going to be ephemeral. We don't care if they're static or not, because we're going to put a load balancer in front of them that does have a static IP address. I'm going to go back to management, and I'm going to scroll down here, and I'm going to turn on preemptibility, and then I'm going to go back up and take a look at that cost, and you can see that dropped that cost down to $37 a month, which is great. And I opted to use a little bit cheaper one, which was $24 a month, because it does, once you deploy the instance, once the management stuff is deployed, it will try to keep these instances running. All right, so I think that's it. Let me double check here. So I've named it. I picked the instance type. I've got to change the operating system to Ubuntu, and I use Ubuntu 18.04. And in my case, I made them SSDs, which increases the price a little bit. But the reason I did that is because SSD drives are faster. But in this case, I'm just going to leave it as the default. And then I'm going to click on Create. And now I have this template that I've created that will start an instance. So if I go in here and I say create VM, it'll actually use this template to create a new VM. Now you could do all this with a script as well. So just keep that in mind, that eventually there will be a script in this repo that will do all this using the script. I just haven't written it yet. That's why I'm walking through it today. Okay, so now that we have that created, what we need next is an instance group. So I already have my instance group created, but I'm going to create another one because we're doing a demo here. So I'm going to create an instance group. I'm going to call this Grub group, whatever, doesn't matter. Grub stream group. And I'm going to say single zone. If you wanted to do multiple zones, I'm just going to leave it as the default, but you can pick where you want to start it. And then I'm going to select the instance template. And so I call that Grub stream template. And then I'm going to leave it auto scaling. I'm going to leave the CPU utilization at 60%. I think I changed that to 80% on the ones that I did. And I'm going to change this cooldown period to 180 seconds because it takes about 2 minutes for it to install and spool up all the services for Grub. And then minimum number of instances, I'm going to make this 2 just to illustrate what goes on. And then I'm going to say maximum number of instances is 4. So what this means is it's going to start 2 instances. They're going to be preemptible. It's going to start them up. They're going to configure themselves and run. And then it's going to watch them. And if their CPU utilization goes over 60% for some amount of time, I don't know how long, it will then start another instance. And that's just so that if the system is being used by people, if people are hacking, hacking away at bookmarking things, and you've got one box imaging stuff, and its utilization goes up to 100% because it's being used, and maybe a couple of people are using one of those boxes, then it'll start another box, and then that box will start imaging things. So kind of a hacky way of like being able to deal with scalability very quickly and easily. This is not complicated stuff. I mean, you saw the code there. It's not hard. All right, so the health check. I created a Grub check, and that check is defined right here. That's all I did to define the check. So I told the application, again, it's a Flask application. I said the application, if you have a requested /h, return OK. All right. So now I'm going to pick that, and that way it will know if the system is up or not. And then I think that's it. There's not anything else to this. And I'm going to click on Create. Now, I want to talk about how I secure these boxes with that token. So there, in the case of Grub, I have a Nginx configuration file. And so when this deploy Grub script is run, part of this is to use Nginx to front end authentication on top of the services that are running on the box. I expose a port number. You could expose any port number you want, of course, to Flask. But in this case, I have it running on port 8983, I think. And that port is then used for communicating to the server by the front-end services, by the load balancer. And you want to do that because if you want to keep your application rules simple or your firewall rules simple, then you can just say, if this instance has a particular network tag, which in this case is Grub, then apply a rule to it that says open up that port. But then the problem is that you don't want to open up the port and have just anybody talk to it. You want to have, like people who have permission to talk to it. So that's why I use Nginx to do it. It's much easier to do that. And the thing is that it also allows me to do that with Solr. And if you've ever tried to get Solr to provide authentication, you will know that it is a complete pain in the ass. And while there may be people who are good at it and they go, oh, it's so easy, you just do this, this, and this. I mean, I ran through the instructions, I called people, and I just couldn't get it working. And worse, I have to wade through Java files, Java logs, to be able to try to figure out what's going on with it. It just makes my brain hurt. So I was like, well, I don't need Solr to do authentication. I can make something else do authentication. And in this case, making Nginx do the authentication with a reverse proxy is a total snap. Saved me time. This is the script, or this is the configuration file that I had to do. And then you saw the script. This part of the script, in the case of the Solr one, is this part right here. I think that's it right there. Yeah, it's this part right here. So pretty straightforward. I have a little script called get token. So this runs the token and creates the HTTP password file for Nginx. And that works for both the Solr deployment as well as the Grub deployment. And again, the Grub deployment is not really, I even hesitate to say, it's really just sort of a little thin Python Flask app running on top of WebDriver, or WebDriver, right? Selenium. And that Selenium's got a port running, and then you have a program that talks to that port to tell it to image it, and then you front end that with Flask, and then you put Nginx in front of it, and with seriously maybe 30 lines of code and configuration, you have a fully password protected tokenized system that people can't get into. And yes, it's all not HTTPS, but that could be solved pretty easily by using a load balancer on Google. And I think this should be done. I don't know why it's still spinning. What's going on? Is there a problem? It says there's a timeout. It's 100% not healthy. Let's go see if we've got some instances running. It says it's got them started. I'm going to go in and look at them. I'm not going to, if these are not running correctly, I'm not, yeah, those are working. I don't know what's wrong with it. It'll probably get healthy here in a minute. Sometimes it takes the instance group stuff a little while to like sort itself out. But in the case of this one, I've got one running and it works. So this one should be working too, but I just don't know what's wrong with it. All right, so the last part that needs to be done here for configuring an instance group that's useful. So we have now a way to automatically restart any instances. So if these instances get killed in here, if I were to take this instance down, for example, and I can't do that here because it doesn't want you to do it because it's in a managed group. But if Google kills this instance, which it will do after 24 hours at some point, it's going to kill this instance, or if it needs its resources, then what's going to happen is the managed instance stuff, the stuff that goes into the managed instance feature on Google, will restart that instance for me. So I don't have to do it. Before, like Solr here, once this guy goes down, I have to restart it in order for it to work again. But to get to the point where it's automated, you just create an instance group, which is what we're walking through. And so, have I yacked long enough for it to work? Come on. Come on, Google. It's still not working. I have no idea what's wrong with it. Eventually I'll have a script that'll start that. So let's go talk about the last step, which is the load balancing part of this. So in this case, what's going on there? This thing is working, for sure. Yeah, I don't know why that's spinning. All right, so I'm going to create a new load balancer, and I'm going to say I want HTTP or HTTPS load balancing. Now I could do TCP load balancing, but why? Because it's running a web service, so it's an API based on HTTP. So I'm just going to do that. You could do it with a TCP port. If you had written a service and you wanted to create an instance template that was running a different type of service, like you were just, I don't know, like some custom thing, not web stuff, you could do this exact same thing. You would just create a TCP load balancer. And what I want to do is I want to do it from the internet to my VMs. Well, technically I'm doing it from my from MITA, which is running on AppEngine, to the Grub servers. But in this case, I'm going to have one or more Grub servers there, and that scales up and scales down using the instance groups. So I don't have to have MITA's code involved in scaling that up and down. And you might ask, well, why don't you just deploy this on AppEngine? And I probably could do that, but again, this is like it's going to take a lot of work to figure out how to configure those containers. Can I run Firefox ESR in a container on AppEngine? I might be able to do that because they're containers. So I might be able to tell it what the dependencies are and run that, but I don't know. It's complicated. So I will need to later, if this goes into serious production and people are using the site, well, yeah, that's going to need to be fixed the best way that it can be done. But in the case of writing code and getting it working, the first iterations of this, there's no point in doing that. It's better to save the time and do it in a secure way. I'm doing it in a secure way. Is it the best way to do it? Probably not. Is it a simple way to do it? Absolutely. So in this case, I'm going to do grub stream LB. That's what I'm going to call it. And then I'm going to click on backend configuration. I'm going to pick a backend service, which is grub service. I'm checking this. I don't remember what I called it. I thought I called it stream something, but maybe it's not running. Oh, Grub stream group. Okay, well that looks okay. So it's finally running. Oh, backend configuration. Okay, so backend services, I guess it's Grub service. I don't know. Instance group, one instance group. Oh, I'm sorry. That was an old backend service that I didn't delete. So the one that is running currently is this one. This is the old one, and I need to go and delete that. But in this case, what I want to do is create a new one. And then I want to call this Grub Stream and then I want to select the instance group. I want to select instance group. And this is all fine, and I want that Grub Stream group in there, and then the port numbers are 8983. And that's the port that the backend service will receive requests through. Maximum backend utilization 80%. I just left that just like it was. And I think that's it. And I'm going to use a grub check on it, which is just pinging that /h endpoint for health. It just returns an OK, and then I'm going to click create. The host path and rules are simple. They don't need anything fancy. If you need to remap stuff or whatever, you can do something else. And then the front end configuration is grub stream front end. And we're going to do HTTP. You could do HTTPS here. So if you were wanting to expose this to the world, in my case, I'm calling this from AppEngine. So someone goes to or calls the API on MITA. Then what happens behind the scenes is some Python code takes over, and then it does a request over to this static IP address, which you saw me put in the configuration file earlier. And then it passes it the token so that it can get in. So that it can get into the system, into the Grub server. But it goes through the load balancer. Well, why does it go through the load balancer? Well, because the load balancer is using an instance group. The instance group then allows me to have Google maintain the servers. So that it pulls up the server and shuts the server down. Like, the thing is with a crawler is that it's not a database. It's not like Solr. So Solr, I need it to remember the data that I send it. In the case of Grub, I don't need it to remember anything. I just needed it to take a picture and then exit. And so in this case, it's like it's a workload. It's like, you know, I'm going to run it. The workload runs. The workload exits. I'm done. Start another server if it goes down. But in this case, I want a static IP address assigned that will talk to the backends. And that's what we were doing here. And in this case, I could create a static IP address. So that's what I did earlier. And I created a static IP address here. In this case of the example, I'm not going to do that. I'm just going to say done. And then I'm going to say create. And then now it's going to create a load balancer for that. And in theory, it should work. I don't know why this guy is still spinning. It says fetching health status. I don't know. It's weird. I know it's working. There's the health check right there. I don't know. All right, well, anyway. So when I started working on this particular feature earlier, I realized, well, it was yesterday, I realized that I needed this load balancer created because if I were to start multiple instances, then either I would have to go in here. I said I was going to show this again. Now I am. Whatever, it doesn't matter. I was going to have to go in here and make this IP address a list. I don't want to do that. I don't want to maintain that list. I just want to put that IP address in there and fire and forget. I don't want to think about it again. I just want to put it in there. I mean, this is not ideal, but it works. And that's the point of shipping something, is to make it to where it actually works and does what you want it to do and what it needs to do for you to be able to move on and finish other things. I mean, it's a blocker. If I can't crawl something, it's a blocker. All right, let's look at this. Is it up? Looks like it's up. So I'm going to go look at the IP address, and let's give it a shot and see if it works. If it doesn't work, I'm not going to sweat it. I'm not going to try to fix it. But it should work. Shift insert. It looks promising. I don't think it's working. Let's hit the health check and see what happens there. Yeah, it's not working. So somehow they're not wired up. I don't know why. It says it's healthy. Oh, you know what? I'm an idiot. I need to take this off. Yeah, I know authentication is required. Authorization required. Yeah. Oh, you know what? I made it foobar. Come on! We're doing it live! Yes! Alright, so now we have this file name, so let's see if we can fetch it from the load balancer. Did that work? No. I think it's, is it control insert is to copy it? Control insert and shift insert to paste it in that shell thing. This is like a git, it's like a git mean W64 thing. That's what I use for managing git. It's like a shell. It is a shell. Okay, so we need, let's see here. Okay, that is the file name. And then what we need is this thing right here. It's, I don't remember. Copy, control insert to copy. And then we're gonna paste this in here. And then images, and then that should work. No? What happened? Image? What is it called? Nobody has said anything to me. Well, there was a viewer. I think that was me on the other one. So hopefully, I don't think anybody's taking my tokens. By the time you watch this later, poor you. By the time you watch this later, all those tokens will be changed. So knock yourself out. Let's look at this. Images. So it's not found. Is that the right IP address? I think that's the right IP address. Why is that not found? Oh, you know what? So the problem is that in this case, if we were to do it with the other one, it would be fine, but in the case of this group, we have 2 instances running instead of 1. So what it's doing is it's asking for, let's see here, yeah. So there are 2 instances here. So if we were to ask this one for it, And we have to do that through 8983, and we have to say this is Grub foobar. This is how you put in the username and password when you're doing a web request. And there you go. So that box has it. But if we go back and we look at the other box, this box, so if we copy this one's, then this is going to tell us it's not found, probably. Grub and foobar. And then it says 404 not found. So that's what it was doing to us earlier. So that's because the load balancer routes between the two boxes. So their load balancer will pick this box, and then the load balancer will pick this box, back and forth. So we put a request in, and it went to this box, and it imaged it, and then it put that image up. But then when we went back to ask for the image, it wasn't there. And that's part of what we want to change today. We want to change about, if there's time remaining, there's 45 minutes. And I need to leave a little bit early, so I'm gonna like trim this down. I'm gonna keep this well under 2 hours today. But I'm gonna talk about what is gonna happen next with the Grub servers, and I'll be doing that stream tonight. So first thing I'm gonna do is I need to tear down this. So I'm gonna delete this so it's not running those instances. And I'm gonna go into instance templates, and I'm just gonna leave that up. Doesn't matter. And I'm gonna go into network services, and we go to load balancing, and I'm gonna delete this one. And then I'm going to tell it to delete the load balancer and the selected resources. The last time I deleted the one that I created earlier before the stream, I forgot to delete the backend services there. So that'll clean up the load balancer and make sure I'm not being charged for the IP address and stuff like that. You will be charged for a load balancer and the IP address by Google, and you're also charged for egress into that. Okay, so that covers all of using Google for all of that. And so now what I'm going to do is I'm going to switch over to talking about the code for the crawler. All right, so this is meta code. Again, this code is not open sourced, but I was going to open source it, and I will be open sourcing parts of it as I have with Grub. The part of Meta that I am going to open source is the authentication system, which uses passwordless authentication using tokens. It's token authentication. So if you log in and you enable it, logins with your phone, or it'll text you a code. If you don't do that, it'll email you a token through your email. So what crawl is doing, if we go to Meta and we look at the docs, and that's the whole purpose of this stream, is that we're going through and coding Meta. That's what I'm doing. I'm showing you everything that I'm doing to do this and talking about it as I go through and do it. I'm going to stick to the subject. I've watched myself enough doing this. I know I wander off into these other areas, and that's probably kind of interesting. I watch YouTubers that do that, and it's good because it kind of gives you an idea of like, what do I know about and what can I share with you that you can learn from. But then the reality is, these are 2-hour streams, and that's a lot of time, and I'd rather put what's useful in here and structured in here, because it'll help me get things done faster. So in previous episodes, we set up the settings. We also implemented the token authentication. So tokens, we should be able to, this should not work. That's right. Is it still having error? Okay. I'm not logged in. There goes my phone. (496.012). 496.012. Okay, now we're in business. Okay, so indexer's working. Oh, we're actually getting documents this time. Man, there's a lot of stuff going on last week. This is horribly ugly, but you can see those images that we're talking about. So all of these images, the MIME type is wrong on that, so it won't actually open it in there. So it opens it as a file, but you can see there's my image Wikipedia. So and if I click on this link, it does not work. I don't know why. It's because I'm doing dynamic. I'm building the page dynamically with dynamically loaded JavaScript. So for some reason that doesn't work when you do that. This is a normal link, and if you click on it, I don't know, the click event isn't firing. So we got to figure that out. So I don't know what this is. American Banker. Okay, Deutsche Banker. Okay, I bookmarked that for some reason. So that I stuck it in there and indexed it. So I don't think the crawler is working. So if we do this, it should not work because I'm modifying all this code in here. So this is probably going to break, but I'm going to do it anyway because I need to know what's broken so that I can fix it. And so there's the error. So it's not working. But that is how I bookmarked these earlier. And so if we look at the token, so this is the API token. This is the token stuff here. I'm just going over this so that if anybody wants to go in and try to use any of this stuff, that you'll understand how it works. So you could go to Meta today, log in. It'll send you a token via email. Click on the link that it sends you in email. Go into the shell, type bang or exclamation token, and then it'll give you your API token. And then do not do this. This doesn't work yet. And then you can go in and do settings. And then, as we're talking about today, we're working on the crawl API. So the crawl API is what we've been talking about. And so what we want to do is we want to be able to take the token from the user making the API call, and then we want to be able to take the URL that we want to image. So then behind the scenes, what's going to happen, I feel like I want to write on a whiteboard, but I don't have that set up to easily do here. But what essentially is happening is we're sending an API request to AppEngine, then the metacode running on AppEngine, then that metacode is then calling the managed group, the managed instances on Google Compute, and it's calling those managed instances through the load balancer, and it's sending that token that it pulls out of the configuration file with it as it does that. So it's going from Google's AppEngine deployment and calling over to Google's compute deployment. So it's making that call, and who knows where that is, but we're assuming that that connection is secure because it's being done with HTTP. And then you say to yourself, well, that's not good. Everything should be HTTPS. And you're like, well, yeah, sure. We could make it that way. We could make that load balancer carry a token, carry SSL certificate on it. But in this case, it's being called across Google's network anyway, so who cares? And besides which, it's not secure data. It's just some URL that you're telling me to go crawl for you. So if there's no like authentication or there's no personal data probably. I mean, if you have personal data on the internet that I can get to with the crawler, then it's not personal anyway. It's not private. So in this case, we're sort of just waving our hands at that type of security behind the scenes. But all of the API calls are being made in a secure manner. It's being made with a secure token that you can replace or update, and it's also being made using SSL connections. So we can make SSL connections out from the Grub crawler box to the internet. So once it goes out, the egress out to the internet is secure, as well as egress from your box or whatever box is making the call to Meta servers are also SSL'd. So it's secure where it needs to be inside the system itself. It's not currently SSL'd. So the idea with the crawl API, and we're not going to get this anywhere close to being done today with this because I only have 40 minutes, like about 30 minutes left, because I'm gonna leave early. So what I'm going to do is try to get some of this format working. So this is the mocked up response. And in this particular case, we've got somewhat of a problem because we have a blocker because we need to upload to the upload APIs, which are not done because we got to finish the crawl APIs first. So we got to finish the crawl APIs to the point that we have the Grub box trying to make the call to upload. And then whenever we get to that point, then we'll have to go work on the upload APIs. And then we'll go back to the crawl APIs and finish them up. All right, so what I have done so far is this. And if we take a look at the old code, I think I've already checked this in, but I know for a fact I've checked it in. Some of it has been checked in because it's not working. Yeah, so you can see here this if false thing. So last commit, I'm going to go through the history, crawl routes added, settings command, and I want to look at this one. Yeah, that's the one. And then web, crawl. Okay, so this, nope. Yeah, this is it. So this is the old code. So in this case, what we were doing was whenever we were getting called, and again, we're trying to mimic this behavior. So I want to be able to post a token and a URL, and then I want to get back a spool object that contains the name of a spool, which is done by calling upload. And if you look down here at upload, it also returns a spool object. And then I want to return where it needs to be uploaded. In other words, what the API target name is for the upload, as well as the URL it was called with, and the title and description of the page, because the spool object can have title and description. And those titles and descriptions either come out of the URL that's being submitted for crawling, or they come out of the user describing the images that they upload directly. And just to talk about that just briefly is whenever we are talking about web pages on the internet, if I have a box that's running on AppEngine, or I'm sorry, if I have a box that's running on Google Compute, an instance that's running there, and it goes out and hits a web page, and that's that user's web page, like they have some web page they've secured on the internet and they need a username and password to get to it, well, I'm not going to be able to see it. But if they went to it and looked at it in their browser, they might be logged in, like Google Photos, for example. Then, well, those photos would be secured with a username and password, but they're logged in. Well, I'm not, if I try to go to that URL, it's going to say, no, you can't get to it. It's not access denied. But if the user went to it in their browser, they could see it. So the idea here is that I might be able to take a picture of the site, or the user might have to take a picture of the site with a screenshot capture, which you can have in a button inside the browser. So in a much later video stream, we're going to be coding up that button so that you can take a picture of the page and then submit it to the system and upload it. And in that case, we'll still have a URL, we'll still have a title, and we'll still have a description, even if they were pictures that the customer who is paying for the service, if they were uploading a set of photos, they could also give a title and description, just like an album would be called. So spools are sort of like albums, but they're also multi-purpose in that they can be referring to URL as well. All right, so I've kind of explained what the spool object looks like. Let's take a look at the actual object. So this is the NDB object model, and NDB is Google's NoSQL database storage stuff. and I use it. If you wanted to not use that, you could totally do it, but I choose to use Google Cloud for these services because it makes it easy, my job easy. It makes it easy to scale things. It makes it easy to do operations. It makes it easy to do development. So that's why I'm using it, is because it makes my job easier, and I don't have to have 3 people working on this. I can just work on it by myself. So in this case, the object has some attributes which include when it was updated. It has an ID for the user that owns the spool. And in Meta's case, for Meta, once a user takes a picture of a website, while I may choose to use that image because it's mine, because they've uploaded it, I may choose to use it internally for analysis, like passing it off to my own machine learning libraries to look at it. In practice, I will not be showing those images of that site to other users in its original form. So in other words, I'm not going to show them a high-res version of it because it could be copyrighted. So if I have a user that tells me to go crawl the New York Times, and I go crawl the New York Times and I crawl the article, which I can do. In most cases, I can run JavaScript and render an article. Some sites like Bloomberg will block you from doing that, but in most cases you can get, with the Grub server, you can get most pages. But that information is copyrighted, so if I were to take that and show it to all users, then I'd be in violation of copyright and I'd get sued. So in the case of Meta, I don't actually allow anybody to do that. You can bookmark it, or save it, I should say. It's not really bookmarking it, it's saving an image, that image, and then you can ask for it later and I'll show you the image that you asked me to take of that page on your behalf. And because you're paying me to do that as a user, then either via the API or the UI, then that's fair use. And there's no way I can be sued at that point because the user asked me to do it. So it's no different than if the user took a picture of a screenshot of a page that they went to and then uploaded it to Flickr. If they shared it publicly, then Flickr could get a takedown request and they'd have to honor it because it was public. But if they didn't show it to anybody and there was no way to share it publicly, then they can't get a takedown request. And even if they did, they'd have to somehow know what the URL was. Then it's not a thing because it's not shared. So when you're developing software, you have to think through not only the code and how it all works, as we were talking about earlier. I've written zero amount of code here, I think. We spent a lot of time thinking about how to write the code, and then we sit down and write the code. Then you have to think about, well, what could get me sued, or what is, like, am I violating a copyright or a trademark or whatever? You have to think about those things, especially if you're trying to make a service that people are going to use, a lot of people are going to use, and you get attention on you. Well, that's part of it. So I've thought through all that. In this case, we're not sharing these things, so they're not public. All right, I've talked too much about that. So here, I've tried to mirror here what we've got. So we've got the name of the spool, so we've got that. We have the upload URL, that's here. The URL that we're saving, the title, the description, any tags, and the file name. So I have that object now created, and from crawl, I can see here that when I create it, I'm creating it with, let's see here. I just saw that I have this Grub response. I need to put this in here. I think that'll probably do it. Where did I put that first? All right, right, so the Grub response, the reason I'm putting that in there is if Grub, occasionally Grub can't get to the URL, like in the case of Bloomberg, it actually denies it. It says go away. And the only way that they know to say that to me is because of my IP address. So they probably use Google Cloud, and they probably use, like, I don't know how. They know Google's blocks. So they don't actually allow a Google instance to go look at Bloomberg. And I want to say it's Bloomberg, but it could be somebody else. Anyway, so they're trying to protect their copyright, and that totally makes sense, which is what I was talking about earlier. Why I'm doing what I'm doing is I'm not showing it to anybody else because that's not right. So in this case, I need to be able to note that there might have been an error talking to the Grub server. So that's what I'm doing here. Okay, so the models are done, so I'm going to close those because I don't really need to refer to that. And the rest of this stuff is all filled in. So at this point, it should create a spool, and it should let me see the spool after I've issued the crawl. So I'm going to tell it to print the spool, and let's see if that works. Okay, so here, this is the part where we need to call the Grub server, which is what we deployed earlier. And we're using requests to do that. Again, remember this code is running in AppEngine. So AppEngine is scaling this up and down for me and handling the deployment of it and all that stuff. And what I'm doing is doing requests, a request out to the Grub server, which I have configured here. There's the Grub URL, which is that IP address and the load balancer that we talked about earlier. And then, and that URL contains the token that's required to get in. So that way, if somebody scans the IP address and sees there's a web server running there, it's going to say, they don't have access, you need the token. And because they don't have a token, they can't get in. So then that's it, right? If they don't have the token. Well, you have the token, but after this, you won't. After I get off of the stream, you won't have the token. So, and then what happens is we're going to load the response from Grub, and then we're going to do a bunch of stuff down here, which is all going to change because this is where we're storing it in the bucket. So this part where we're storing in the bucket needs to be moved into these upload APIs. So here we've created the spool, but now what we need to do is we need to fill in the title and the description, which is the part we're going to finish today. And then this part, all this bucket stuff needs to be moved into the upload handlers, and that's not in there yet. And all of this stuff will need to be changed, but that will be done in the next episode. So hopefully tonight we'll get to that. Okay, so the part that's missing in here is this soup stuff. So what we want to do is we want to import HTML crawl from soup. All right, so that's going to import that. Let's go over here and see if we've got, we've always got errors. So it says here, from web crawl import crawl handlers, it says in crawl py, web crawl py line 94, if not public URL, invalid syntax. Line 94. And the reason why is we put this inside of try except we didn't have any except. So let's try that. Line 119, expected an indentation block. And keep in mind I'm rewriting all this. So all this code was here. I wrote all this code, this crazy code. Tokenized title, tokenized description, words, tokenized title, tokenized query words. This is where I'm building the document to send it into Solr. So I don't want to do that now. What I want to do is I want to let upload do that. So I'm going to create a spool object, and then I'm going to send it to the upload API after I have created a spool and told Grub to crawl it. Then I want to return to the user the spool, and then they use the upload API to query the spool to see if Grub is done with it yet, or if somebody's finished uploading to a spool that they've created. There's a function here. It says post u. No, that's the upload. There's a post. Yeah, just the post to u creates a new spool. So we're going to need to do that in here. We're going to need to create a new spool. I'm sorry. Let me back up. Crawl creates the spool here. It creates the spool, but we will also need to create a method, endpoint handler for /u that also does this exact same thing. So it'll have this exact same code here that it'll create a spool and then it'll return the spool. It'll return the spool name. So in this case, we're going to print spool. Can we run? Nope. Soup is not defined. All right. Soup is not defined. Title soup. What did it say in that? Soup pie. Do I have something at the top of this? Oh, I haven't saved this. There we go. All right, now we're running. All right, let's pull this up and see if it works. Seven two four 842. 724 842. All right. No, I want to. What do I want to do here? I think I want to try to make the call. I want to make this call. Shift insert. An error occurred, and this is the fail, okay? In this case, we're actually calling the wrong thing. This is localhost. We're doing dev, right? All right, that looks better. Okay, so title is not defined in crawl.py, line 66. Yes, and that's because we need to do an else, and then we need to do, what is it called? HTML crawl, and then we need to pass it the URL. I think that's right. I figured out how I did that. It's like that. Up and down arrow. So that's Control Windows up and down arrow does that. Okay, so we saved that. I'm going to save this, and then we're going to run that again. Now we've got URLs is not defined. Okay. Where is that? Do we print anything? No. Nothing has been printed. Okay, URLs is not defined. Oh, that's in soup line 12. I just moved all of this code around, so. So before I was, when the user, so if the user is in the shell, and this shell will, the view will change here, but if they did something like this, for example, they could also do something like this. For example, right? And if they do that, then I'm just going to see what the error is, just out of curiosity. Expected string or bytes like object. So it's regex is barfing on it. So in that case, I could extract both of those URLs and crawl both of them. I wanted to support that because whenever I built the builder stuff, which is the parser for the line that the user is typing in, the whole idea here is it's like a bot you're talking to. So the sidekick is like a bot. And you can have a conversation with the bot, which is basically around saving URLs or saving data or saving pictures or whatever. It's not just for URLs, so it's not a bookmarking site, but it could be used as that. But it's not intended to be a bookmarking site. So in this case, I was expecting that I would get past a list of URLs, but in this case I'm not, so it's just URL. And then I need to scan through here and make sure do I have any other URLs? I do, this one right here. So if there's no title, I make the title the URL. I don't know, what else do you do at that point? So I say, I use Beautiful Soup. So I open Beautiful Soup and I say R text. So I do a request for the URL, sending headers, which originally were in here. This thing right here. So we want to pretend that our user agent is Mozilla 5.0 Macintosh. This is actually what my user agent was on my computer. And so I set that because I want to fool people into thinking that when I'm calling them from Python using Beautiful Soup, which is only doing HTML text, it's only the source code of the HTML, then I want them to see that my user agent is that. I mean, you can ask for data from a website, and if you pass them a certain user agent, as your browser will do, some sites look at that and say, oh, you're passing a user agent that isn't Mozilla 5.0 or whatever, I'm not going to talk to you. Well, that's their prerogative, I guess, but then it's kind of silly because I can just fake it and put it in here, so you really shouldn't do stuff like that. If you run a website and you're looking at the user agent and making a determination about what data to return based on the user agent, don't do that. It's dumb. Because the reason is somebody's just going to go in and change it. So then it's an arms race. They change it like I'm doing here, and then you got to do something else like what Bloomberg's doing with IP addresses on Google. The Bloomberg is like, well, I'm just going to go. I keep saying Bloomberg, but it might be Reuters. I can't remember who's doing it, but it's either Reuters or Bloomberg. And then they're like, well, what's your IP address? I see your user agent you're saying is Mozilla, but then whenever you're talking to me, I'm not getting cookies, so I want to know, in the case of this, I'm not giving them any cookies. I'm not returning cookies to them, right? Because I'm using Python. They're like, well, what's your IP address? Oh, I have an IP address that says, IP address table that says, you have an IP address, I'm not going to talk to you because you're a crawler probably, or you're like scraping my site. But yeah, there are a lot of people that scrape shit like that. You know, there's like when I was talking about PageRank earlier, there's a bunch of people, unethical programmers, who go out and they scrape websites. They actually scrape the HTML and then they pull out the content and then they paste it in their own pages with those links. And then they make links to other sites that are paying them to increase their page rank. And then they link out to them, and then they have this fake page that has all of this content on it that then they try to get Google or whoever else. I mean, it doesn't, like, if you're a search engine and you're not Google, well, then who cares? Like, maybe Yahoo or MSN, maybe, or DuckDuckGo, but like, if you're not Google, then it doesn't matter. They try to get Google to come in and crawl them and think that they're relevant somehow because they have New York Times content on the site. I'm not doing that. I don't want to get into that business. That's not what I want to do. I want to be able to let the user that wanted the New York Times page bookmarked to be able to go back and search for content on that page, and I want to give them that link, and then I want them to click on the link and go and look at it. And then I want the image so that I can have our machine learning libraries look at that image and tell the user something additionally important about that page. I want to be able to use it to increase the rank of that page for the user. I want them to go back to New York Times though. New York Times owns that content. I want them to go back there. So it's silly to try to fake it. Okay, I'm ranting again. Okay, so that's why you come in here, isn't it? To watch me rant? Or watch me code. Who knows? Okay, so leave a comment in the section below. And be sure and like, subscribe, and share. So here we're saying, okay, headers, so we're going to make a request out to the URL. The only reason we're doing this is because Grub has not crawled it yet. So Grub has not imaged the site yet. Grub is going to be called in a moment, but at first what we want to do is get the title and description if we can. And that's not going to work, as we showed on Hacker News. Not everybody has that. If we get a 302, we need to deal with that. So should deal with redirects. We should deal with redirects. Because if we get a redirect, we should probably tell the user, hey, this is actually redirecting to this other URL, so we're going to take that URL instead. And that does happen. So 302s are a thing. Okay, so we're going to, in this particular case, we're going to go ahead and try to hit the URL without respecting the 302. Hopefully it's redirecting us correctly and giving us the data. Sometimes it doesn't. And then we're going to try to get the title and description. That's what all this code does. And all this code needs to be cleaned up. I'm just brute forcing all try and accept stuff. Like all sorts of stuff goes wrong when you're trying to hit the web. But what happens at the end of this should be, what are we expecting as a result here? Yep, right here. We should, we need something. We'll call it result equals HTML crawl. So at this point we should have stuff, and we should have a title. We should have the URL equals URL. For now we're going to make it URL. But here in a minute we're going to make it, I don't know, let's go ahead and make it result. Because if we get that redirect, we might need to update the URL. So the result URL, we're going to get the title, is going to be the result title. Now we're writing code. And then description equals result. What? Are you serious? Okay, whatever. Who knows? Maybe it's because I haven't saved it. Alright. I don't know. Who knows? Okay, so, and then tags, we don't need that. And then the Grub response. So, equals result. Seriously. Yep. All right. So those are the things we're expecting back from soup. Yes. So result equals, are we using result anywhere else in here? I don't think so. Okay. Result equals response equals success, and then title equals title. Being a dork. This is a dictionary board. All right. Yes. I do this sometimes when I'm coding in Flask and this framework for AppEngine, because there's this. You have a dictionary, and then you have where you have to assign it to the storage object anyway. It's kind of like if you spend a lot of time coding JavaScript, and then you switch back to Python, you end up putting like semicolons at the end of your lines. Totally do that all the time. What else do we need? URL, title, and description. Okay. And then we're going to return that. Yes. All right. So let's give that a whirl, see what it does. It says no connection adapters were found for HTTPS. Maybe that's because it's, where's that? Line 16. What are we passing? What is, let's see here. So I think that URL is probably a list. Yeah, it is. I kind of want to respect that. And I just like hacked it all up, didn't I? It's just here. Oh, so I have this function called find URLs. And I think that's a regex that was breaking earlier, which is in libutil. I don't know about this thing. I was kind of kicking around. Well, this returns a list. Technically, it's only returning one object, which is the first one. And I probably shouldn't. I'll come back to that. That's what's always good, is like if you're like, well, I'm going to come back to that. Well, okay, well, how much code are you going to add to like hack it up? Well, not much. So in this case, I want the first element of it. All right, and then I'm going to put on here, fix this. Because it does need to be fixed. It needs to be like you have to think about, okay, so there's code here. You can either have a list of URLs or not. The user could type in 2 URLs. So do you say so right now I'm not handling that. Like in this case here, this example, I've typed in 2 URLs. Yeah, it broke, but the user can do this. The user could give you 2 URLs. What do you do when they give you 2 URLs? Well, you have to figure that out. In this case, we're only going to take the first one, so we do need to fix it because we either need to tell them you can only give me 1 URL, or you could take both URLs and crawl both of them for them, which would be the nice thing to do. That's a little bit harder thing to do, but that's what I was shooting for here, is being able to handle both of them. And in theory, that's okay. It should be pretty straightforward to do that. Okay, so that should work. Now I've made it the first element. And now what do we get? We got an unexpected keyword argument grub response. Where was that? 78. Okay, so that's at the end. So you can see here, this is the end. 78 is the line right before the end. So that means it comes from outside of this, or inside of this somewhere, which is that Grub response. And it says pending. And the reason why that's broken is because we didn't finish the model. See, that worked. I don't understand why the other completion didn't work. Oh, it's not a datetime object. Trying to figure out why this says this. It's kind of odd. I don't know. Wasn't paying attention, so I'll fix that timestamp thing now. Yeah, that should work. Okay. Create got an unexpected keyword argument grub response. Same thing. What line? Line 78. Same line, isn't it? Yeah. So what did it say? It says create got an unexpected keyword argument grub response. I know that it's going to do the same thing. Okay, so that's in the model. It's right there. We're at 2 hours, so I'm getting ready to roll. Okay, so I'm going to fix this problem now. Got an unexpected, let's see, file names. Got an unexpected keyword argument grub response. Are you sure? Well, what is it? Spool create, I've saved this. This is saved. What if I just take this out? What's it gonna do? What are you gonna do now, huh? Got an unexpected keyword argument URL. For Pete's sakes. Spool create. way it's saying that. I mean, it didn't seem to have any problem with the URL. What is it doing? It seems very odd. Okay, well, I don't know. And I gotta go. So that's sometimes the way the stream ends is that I just don't know. So I'm gonna take a break, walk away from it. I'll come back to it and look at it. But in this case, I'm calling it, it's marked with a class method, which means that it should expose it as this object, which I'm importing up here, spool, blah, blah, create, user ID. Oh, well, that's right. I mean, I'm setting the URL, the user ID, the title, the description. But I can take all those out. Maybe we'll do this. See if that'll make it work. I just wanted to print the spool. No current context. NDB calls must be made in context established by Grub. Oh, that's because I have to, when I'm printing it, I have to print it in a context with client context. Because it's a spool object. Yep. It's a database object, so I have to do that way. Okay, there it is. So now I'm printing it, well, less than ideal, but that'll work. And I don't think this is going to come back ever. It's hanging. And the reason it's hanging is because it's calling this stuff down here. But anyway, we'll finish that up in the next episode. What I'll do is I'll figure out why this was happening. It's so odd, this part. I don't know. It's probably kind of obvious. Anyway, I'm Cord Campbell. If you've enjoyed this, make sure you like, subscribe, and share it with somebody. Whatever. It'll happen. One way or the other, I'm launching this thing, and this is sort of the format I use for doing it. So if you're interested in the service, go and sign up at https://meta, mitta.us. If you have any questions about the service, you can email me. My email address is cordless@gmail.com, and I hope to see you soon. Take care and have a great